Howdy, folks. This is Dr. Matt Grieshop, Director of the Grimm Family Center for Organic Production and Research at Cal Poly San Luis Obispo, and you're joining us for Organic Chat. I'm here with Shane Egerstrom. He's a graduate student working with the Organic Center. Shane, why don't you introduce yourself to the audience?
Hey, thanks for having me. Yeah, I'm a master's student. I'm working for Dr. DeCock, doing some research on some broccoli field trials out in Santa Maria and eventually Salinas, because the project's still in progress. And we're looking at nitrogen use efficiency in these crops and how it's affected by irrigation management. So,
cool.
And we're comparing the kind of organic tie-in is we're comparing how management is also affecting these practices. We're doing 8 fields, and 4 of them are going to be organic and 4 of them are going to be conventional. So working in both spheres a little bit.
Excellent. And it's all in broccoli, you said?
It's all in broccoli, that's correct.
Okay.
Yeah.
Cool. So for our audience, how might irrigation, what are some of the ways that irrigation might affect nitrogen management in these crops in our region?
Yeah, well, like a big thing that there's this really novel idea of pump and fertilize where we have all of these very heavily polluted groundwater river reserves of water, and it's just like pretty dangerous levels of nitrogen contamination, but crops need nitrogen. And it's kind of a very nice solution that we can just apply that fertilizer, that water back on, and ideally in a perfect world it'll be taken up by the crop again and that'll clean the water. But in practice it's not really the way that things have shaken out, where everything that's in the water can be taken up by the crop. So we're trying to quantify if there's certain irrigation practices that are going to make that fertilizer stay longer in the root zone, then maybe the nitrogen will be taken up more effectively by these crops.
Okay. Yeah.
That's kind of the idea of the research I'm doing, because there's been some previous tests that have been done that you've applied pretty absurd amounts of nitrogen just through irrigation water, and it's not really been taken up by the crop in a way that's effective.
Right.
Even if it should be fully enough for the crop for a season to be applying 300 pounds nitrogen per acre.
Just through the water?
Just through the water, yeah.
Wow. And so the irrigation styles you're talking about, I'm guessing like you're comparing like overhead solid set irrigation.
What we're
drip,
using actually is we're using Crop Manage.
Okay.
So that's an evapotranspiration based irrigation system.
All right.
Which developed by Michael Kahn, and it's a really handy tool for something that's completely accessible to the public, and it's just free for anybody to play with online.
Cool.
Where you can count for soil type. It takes data from the soil surveys, and it goes from the local CMIS stations and takes data from that, from precipitation.
Okay.
It does some crop coefficients and stuff like that. It takes a lot of data in based on trying to give you a very precise measure of how much you need to irrigate at each event. So.
Okay. So is that the irrigation style that you're looking at in terms of keeping that nitrogen-rich water in the root zone? That's being affected by timing based on crop manage?
Yes. More
so than the actual so like flood versus solid set overhead versus
the delivery will be the same for us, because we're doing these trials in the same field.
All right. Yeah.
We're like, it'll be done all through drip.
Okay.
Yeah, we've got drip lines, and I've been building these manifolds where it kind of splits some of these rows, so I can have randomized by each row.
Oh, okay.
One drip line will be on one layer of the PCV that branches off their main line, and it can be turned off at an earlier time based on the recommendations of Crop Manage. So, maybe Crop Manage will recommend 4 hours, and the grower will say, oh no, I think I would do 5 hours, so we just turn one of them off 1 hour sooner.
Okay.
That's kind of how it works out in practice. But
all right. So it's the timing of irrigation and trying to manipulate that so you can maximize the time that this nitrogen-rich water is where the plant can actually access it.
Exactly. And minimize leaching, ideally.
Right, right, because you don't want it to go back into the groundwater, which is where it's coming from.
Yeah. I think, if you're applying less water, you're leaching less nitrogen as well.
Hopefully, right?
Yeah, hopefully.
So how do you think the organic treatments are going to play out with that? Or what's the sort of running hypothesis in terms of, what you're going to see in the organic blocks versus the conventional blocks?
Yeah, it's interesting. And for something that I'm like a little bit new to, it's exciting to see. I'm really excited to see what kind of data we're going to get in. But definitely my perspective of organic agriculture and organic systems, there's going to be a different kind of soil health aspect there. And kind of like how nutrients are cycled through, because obviously in these conventional systems you're going to think of all the nitrogen in there just being basically in nitrate form. Like we move through the water pretty easily. When in organic systems, there's probably going to be a lot more cycling that's happening, through all these pools, through these organic pools and, non-plant available forms that are probably going to be a little more active and store a little bit more nitrogen in these forms that aren't going to get leached as easily.
Right, because there's, typically more carbon going into the organic systems, even if they're not using something like compost. The fertilizers they're using have a pretty high carbon to nitrogen ratio. Certainly relative, a synthetic, 45% nitrogen fertilizer.
Yeah. Right.
So yeah, it will be really interesting to see how that plays out. So how are you collecting the nitrogen data in the soil? Are you taking soil cores at multiple depths, or are you putting lysometers in, or what?
We are taking soil cores at multiple depths. Yeah, we're taking soil cores down to 3 feet at each.
Oh my goodness!
Yeah, yeah.
Right. That's why we need a power tool for that.
That's why we need that handy new power tool.
We have a power tool. Yeah,
it's been really essential.
Yeah,
it came at just the right time, really, for my project.
Yeah,
which is quite nice.
No, I know it's been well received by the soils team. So,
yeah.
So for the listeners, we have an automated. It's basically kind of like a pneumatic hammer kind of setup that runs off a little engine, and it drives the soil core into the ground versus you having to do it with a sledgehammer.
Yeah, which was the case for my first ever soil sampling day.
Yeah, that's how I think I haven't used that piece of equipment yet. I think every soil sample I've ever taken was by hand, and for some crazy reason, as an entomologist, for a while we were using golf plug cutters because we wanted big soil samples.
Oh, really?
And that was a nightmare. But it got samples.
What depth were you taking them to? I wouldn't like.
A golf plug cutter cuts to about 8 inches.
Okay. Yeah.
Yeah, and you get a pretty solid plug out of it, and it has a little pusher so you can extract a pretty intact soil sample. I don't remember why we thought that was important. Eventually, we went to just a normal soil probe. I think because we were entomologists and just being silly. That's
what were you monitoring as far as like?
We were looking. So in that study, I think in the first study we did there, we were looking at residency of entomopathogenic nematodes. So I had a graduate student who was applying these en masse on an organic apple orchard, and then we were trying to see how long they were resident. So we would use these plug cutters to get a big intact soil plug, and then we would expose some target critters, insects, to kind of see if they get infected by these nematodes that live in the soil and attack insects. We were targeting codling moth and plum curculio. Ultimately, we didn't find much in that study. What we really found is that the entomopathogenic nematodes just seem to be everywhere all the time, and that our meager applications of them a couple times a year didn't have much of an impact on it, on their standing populations or their residency. There was maybe a slight blip for about a week out, and then after that, it was pretty much our controls and treatments all looked the same in terms of numbers of critters succumbing to nematodes and plugs.
Interesting.
But that's a whole different thing. And then I think we continued using it because we had it, and then we switched to soil probes because it was a lot easier.
Yeah.
But we weren't going down to 3 feet ever. I think, for us, a foot would be probably as far as we'd ever go.
Yeah.
Yeah.
It can be a little tricky, even with the manual probe, but much easier, especially if the texture is working right then.
Yeah. Well, you get into a heavy soil like we have on campus, and I can imagine wailing away with a sledgehammer for 30 minutes.
Oh, man.
And then hitting a rock. That's how it would work if I did. But I'm sure that's never happened to you.
Oh, yeah. I've never seen a rock in there.
Never seen a rock.
Never encountered a rock, yeah.
Never getting rocks. Okay. That's good. Well, since this is organic chat, I always like to ask a few questions about, your perceptions of organic ag, sort of what's got you doing what you're doing. So, Shane, can you share with us what are a couple of things you think about when you're thinking about organic agriculture, or what does it mean to you, and why are you involved with it at the research level?
Yeah, I like this question. I think I've been thinking on it a little bit as I listened to past chats, and I think I kind of want to talk about. I want to touch on what I kind of thought of organic agriculture before I came here to California, maybe too.
Cool.
Because I don't know, I've just, especially in the past, in my postgraduate work as well, where I've really, in my research, my senior year, where I've really dove more into agriculture. And when I first started, this kind of environmental science and soil science background. But yeah, I feel like it's so interesting looking back now and just thinking of what my perspective of agriculture was growing up, where I was like, okay, yeah, organic food is good for you. It is healthy, and that's because it does not have pesticides.
Right.
And the other ones must be coated in chemicals.
Right.
And I don't know, there wasn't much more that I knew about it other than that's the one with the chemicals on it.
Right. Well, yeah, and that's, I think, a common perception is that that's the major difference. I mean, the other one, less so now that there's other genetically modified crop labels, but that was another one that I think a lot of folks, it's like, oh, it's not genetically modified, which it isn't, because you can't use genetically modified anything in organics. But so how's that changed? So no pesticides, which is a kind of a misnomer too, right? Because we absolutely do use pesticides from natural sources and in a lot of specialty crop organics, because we have the same pest management issues that conventional growers do.
Yeah.
We don't. What we use and how we use it is different. But yeah.
Yeah, it's interesting. I think now that I have such a soils background, I think a lot of my perspective now is when I think about organic agriculture, is thinking about the inputs. And obviously the research I did, even with the center in my undergrad, was all about organic fertilizers. So that was... that's obviously going to stick in my mind.
And it's funny that you've come to that too, because if you look at the organic movement, so if you step aside from certified organic agriculture in the United States as it currently exists under the USDA, the movement was really rooted in soil, and it was really more about fertility than anything else. And I think that's something that hasn't been very well communicated to the public. I mean, what I hear when I tell people what I do and work in organic ag, they immediately jump to the pesticides thing. Yeah. Sometimes fertilizers, rarely, but rarely do I get a bunch of questions about soil next, which is interesting, because that's really, again, you look at the Howards and the Balfours and the Rodales and these folks that were so important to the development, and they were just all about soil. It was all about, hey, how do we feed the soil? How do we build a healthy soil? If we have a healthy soil, then we'll have healthier plants. If we have healthier plants, then we've got better products, whether we're feeding it to an animal, a person, whatever. So it's interesting to hear that you've kind of went this backwards journey a little bit, where it's like, okay, you started where we're at, really post National Organic Program, where people's perceptions are really more about these pest management inputs. But now you're thinking about, soil.
I'm certainly
which is the soul of organics. I'm
thinking a lot about soil.
Yeah,
that's certainly what I do.
Yeah. So what are your perceptions of how that soil management is different based on what you've learned so far in terms of organics versus conventional? In broccoli, for example, the system you're working in.
Yeah, I think I associate organics very heavily with these ideas of sustainability that are just, I don't know, it's a word that gets thrown around so much, and also maybe the meaning gets muddied and confused as well.
Yeah, it doesn't really have one definition.
It's not quite clear to nail down. But when you talk about soil health and sustainability from that kind of perspective, the idea of being able to manage the same land in the same way for generations and generations is kind of something that appeals to me, and appeals to me about organic agriculture, and feels like a more viable strategy than maybe more conventional methods, where things, I don't know, a lot of the nutrients get ripped out of the system, and it's just a little harder to keep that up.
Yeah.
For many generations.
Yeah. Well, so much of it, in my mind, it just comes back to organic matter in the soil, right?
Yeah.
Which is, so if you don't have carbon, it has massive impacts on your texture, which is going to affect everything else, right? I mean, your aeration, water and porosity, buffering capacity for pH, for phosphorus, for nitrogen, for and it's interesting to hear you talk about that. And then also it's interesting to hear you talk about this concept of growing food on the same ground for a long time, because again, if you go back to those early organic thinkers, that's really what inspired them. I mean, these folks saw
talking about Indian agriculture.
Yeah, Indian agriculture or Chinese agriculture, and the fact that you had these intensive ag systems that had managed to maintain soil over thousands of years of intensive cultivation, and then that juxtaposition with what was happening as we very rapidly, went to synthetic fertility and a lot of tillage, which we till a lot in organics too. But
I hesitated to talk about tillage.
Well, I mean, it's just it comes down to how much carbon are you putting back, right? Mm-hmm. And so going back to your research, I think it'll be fascinating to see if you see any marked or consistent differences between your pairs of organic and conventional fields. Because in theory, if they have been building organic matter, you think you might see a difference in terms of nitrate leaching, or at least retention. But maybe you won't. I guess it's why it's research.
Exactly.
Yeah.
All about questions, all about what we don't know.
So a question I like to ask students who work on the farm and you're doing research and it's off campus and stuff is about, sort of like biggest farming mistakes and successes. And so I can't really ask that question of you, but what I can ask you is, so in your research experience so far, what was the biggest, and mistakes are really only failures if you don't learn from them, right? I mean, that's how we learn. We try something, it doesn't work, we figure out why it doesn't work. So what would you say? What are a couple of your biggest sort of like, oh no moments in your research career so far here at the center?
I do have one that comes to mind that I think I'm a little bit notorious for, actually. That was regarding when I harvested all the broccoli off of the first conventional field that I did.
Okay.
And so part of the process of how we're measuring nitrogen uptake is we're going to we take subsamples of these broccoli heads that we harvest, and we measure their weight, of course, and then we take subsamples of other heads and we dry them out and then run them on a carbon and nitrogen analyzer. Mm-hmm. There's a combustion method that measures the carbon and nitrogen that's in that material. But for that part of it, I was under the misconstrued perception that I would need to dry the entire heads of all these broccolis that I harvested.
Oh, wow.
Which was just, I think it was about it was a lot. It was probably 10 pounds times 30 or something like that of broccoli heads.
So 300 pounds of broccoli heads.
Maybe less than that. Maybe I'm exaggerating a little, but it was certainly
a lot of broccoli.
It was certainly a lot of broccoli.
A lot of broccoli heads.
And there's not that many ovens that we have at our disposal.
Yeah.
So I just kept on.
So you were that guy.
I just kept on talking I was like, oh my God, how am I going to fit all this in here? I think I had broccoli heads drying in 3 separate lab rooms.
Oh my
goodness. And the thing about the drying broccoli is there's
a lot of water in there.
There's a lot of water, and there's a certain smell that is quite pungent
that's
sort
coming
of
off of it. Kind of.
Oh yeah.
So you're really popular with your
There
lab mates.
was a point where if you'd be walking into the D18 lab building, you could be about 50, 75 feet away in the hallway, and it would start to hit you when you're approaching the room.
Sulfur.
Yeah, there's that broccoli smell,
Yeah. I kind of enjoy when I walk into a broccoli field, that smell. But I can see where if you're drying it down and concentrating it, might be a little pungent.
We had to keep it going for a while.
So it sounds like you probably ended up with pounds of dried broccoli at the end of this, potentially that you didn't need. So, because you probably took a subsample from each of those, and then
we just had to take a subsample of what was dried, so we could have just done that ahead of time.
So
dried it out very easy.
So, is there any culinary possibilities for dried broccoli? I mean, is this the new power snack?
It didn't quite strike my appetite after a couple weeks of experiencing that
wasn't
smell.
Edible. Okay,
it wasn't striking many people's appetites.
Well, I've seen carrot chips, so I had to ask.
Yeah.
I don't know if I've seen dried broccoli.
I know. It was actually funny. I think Allison somehow had some sort of dried broccoli snack, and it was very similar to what we were sampling. And they would have it for lunch, and then they would have it for lunch one day, and they would walk right back in and weigh out the broccoli that was dry in the thing. And
that's kind of odd.
It was a back and forth there.
Yeah,
I'm not remembering that.
Well, that's not. I mean, as far as that sounds like a good learning experience, but I mean, you didn't lose any data. So as far as
no, I didn't lose any data. I almost did. I was worried about some of the broccoli was spoiling. It ended up being okay, but like it had been like a while, and I was like, I can't keep this broccoli out here still. Like, this just needs to dry out. I don't know what's happening. And then I finally figured it out. I finally talked with Charlotte like really in depth. But it's sure. She's like, wait, what do you mean? You subsampled it all, right? I was like, oh no.
So how much broccoli do you actually need for your research per sample? So if you did 10 pounds.
Well, our strategy is more by like. We measure the yields by area. So what we would do is we would just take a 10-foot plot of our 100-foot.
Oh yeah, but for your analysis in the lab, like how big a sample of broccoli do you need?
So little. Well, we're gonna grind it. We grind it with a coffee grinder before we put it on the combustion thing. So it's like probably just a couple grams.
Oh,
like,
okay.
It just needs to be uniform and like mixed up across several heads is the best. It's all about subsampling.
Yeah, just like
kind of thing.
Doing a soil. Aggregate sample, right?
Exactly.
You're not going to take everything from one broccoli head. You're going to take little florets from multiple
piece from here, little piece from here, mix it all together. Yeah.
Yeah. Okay. Well, that's good. I mean, I'm glad you figured out.
Yeah.
I mean, I'm sure it was a huge relief to you too. I mean,
no, it definitely was. I was like, how is this possible? I didn't get it. I had COVID around that time too, so I think there's some COVID brain things happening, but
yeah, that sounds. I mean, when we're learning research, and I mean, I don't think it ever really stops. You end up kicking yourself a lot later because you're like, for example, earlier, we were talking about soil sampling, and I had a host of grad students in my former lab that. For a while, we were using golf plug cutters for taking soil samples because we needed them for one particular project, and then we just kept using them. And I was doing it too, and it was a nightmare. I mean, it's a big, heavy implement and a lot of soil when a probe would have done just fine. So you're not alone in that. That's how we learn.
I feel like that's another lesson I've learned in research. It's easy to like. There's so much work that needs to be done a lot of the times, and so much repeatability that you can just kind of get into the swing of things where. It's really important to kind of take a step back all the time and be like, okay, reanalysis, make sure we're really achieving the same goals here with the procedures that we're doing, before I go into machine mode and just do 120 of these samples,
Right, you got to find the method before you start the grind.
Yeah.
And you're grinding even, but otherwise, you can end up doing a lot and not learning very much, or end up, driving people out of a lab running from the sulfur broccoli smell.
Yeah, that is the humorous part of that story because I still meet people because I put all these signs on all these doors where it's like, I'm sorry, I'm behind Febreze. This is my contact. You can yell at me here.
So you get calls in the middle of the night. Hey, broccoli guy.
I exposed myself to potential hate. I didn't actually get any, but
well, that's good. I'm glad. Well, it's a pretty forgotten community.
People recognize me when I've introduced them. I've met some new people and they've been like, hey, you're the broccoli guy from the like, oh man, I've got a rep.
Have to make t-shirts now. So the flip side of that question, of course, is something that you've been doing in your organic farming research that was a really big success. I mean, what's something that's just worked out beautifully or beyond your initial hopes?
I don't know. I think it's easier for me to look back on my undergraduate research right now and like kind of be proud at something that's more like in a finished stage.
Yeah.
And like, I don't know. There's just so much data collected for that. And I think it's just for me to like be able to look at that data again and see how these, I guess I didn't talk about research at all, but it was about how these organic fertilizers, what's that?
I was going to ask you.
Yeah.
So, yeah.
Yeah, it was about how these organic fertilizers are affected by temperature and how the mineralization curves are affected over 5-week incubations. But we tested a bunch of different
12 fertilizers.
12 fertilizers. Yeah, there was a bunch of different feedstock supplies and
5 temperatures.
Yeah, 5 temperatures.
Yeah, 60 treatments.
Yeah, 5 to 25 degrees Celsius. which I should remember the Fahrenheit equivalents to that, but not quite. But yeah, I think it was just a really interesting to be able to see something firsthand in how things move through the nitrogen cycle, and how at certain times it was moving out of the... we found this kind of like temperature limiting effect from moving from ammonium to nitrate, where at lower temperatures the more ammonium was building up in the system, and then at the higher temperatures it was moving to the nitrate form a lot quicker. And just kind of seeing these cycles that you learn about through the nitrogen cycle in class, like firsthand, and like seeing it in your own data and be able to put that together for yourself, I feel like I got a lot of satisfaction from that.
Yeah.
I'm quite proud of it.
Yeah, that was a fun experiment. That's actually one of the first fertility experiments we got going when we started the center. So Charlotte and I were at the core of your suffering with that one. And we had some support from Grimway on that one. But yeah, I've actually had a number of folks request that data from growers from different commodities, and it's been well received. Then it's pretty straightforward and simple. I mean, the experiment was pretty straightforward and simple in conceptualization, but it was a tremendous amount of work. I mean, thousands of extractions.
It's a lot of extractions. I've definitely got my potassium chloride extractions down now.
But pretty neat in terms of what it demonstrated about how a compost-based fertilizer versus like a dairy manure compost-based fertilizer pellet versus one that was heavier in bone meal, feather meal, like how quickly they break down, and then that temperature interaction. The next piece that I would love to add to that, but I don't know if we'll ever do, is looking at a range of soil types, because we had that other experiment that Charlotte led just prior, where it showed that
was with Christopher, right?
Yeah, with Christopher, and she's I didn't meet her actually, but she was an exchange student from Korea, I think. Song-yi, yes, thank you. I didn't meet her, but that one was cool because they used one fertilizer and then looked at these 72 soils, and basically some of the soils were locking up 40% of the available nitrogen in the fertilizer immediately within 7 days, and some of them were releasing 80% of it. And so it was this, the experiment you did was really focused on, okay, these intrinsic factors to the fertilizer, how do they affect the nitrogen release curves of, which is important because we want to match those with the plant's demand. That other experiment did the other thing and just said, hey, these things that we don't really control with an input, it might be something you could alter over years of careful stewardship, but what happens there? And really what we found was the variance on those 72 soils was far greater than what we saw with those 12 fertilizers. Wow. In terms of how quickly ammonium and nitrate were mineralizing. So I'm absolutely fascinated by that, and whether we can get to the point where we can better predict how this works. And I'm an entomologist though, so there's better soil minds than mine working on it.
Yeah, it's very interesting, especially with these ag water 4.0 kind of pressures, and I'm not sure. I think maybe the status of Ag Order 4.0 might be
so for our listeners, Ag Order 4.0 is a local water district policy in parts of coastal California where basically, because of the nitrate well pollution that Shane was talking about, there's a mandate where growers are allowed to put on so much nitrogen, and they balance that with the nitrogen calculated to be removed by the crop. So the work that Shane's doing with the broccoli actually kind of ties into figuring that piece out. And it's the amount that you can put down versus remove shrinks over time. So basically, it started at like 300 units, and then eventually it's supposed to get to like 50 units of nitrogen or 50 pounds of nitrogen per acre, which is really low. Yeah. Maybe not feasible, but for a profitable crop. So it got struck down by the statewide water board in, I want to say, late 2023. Basically, the larger state water board said, no, this supersedes your bureaucratic power, whatever. You have to comply with the state board. But I know there's already more discussions about this, and the farming community, I think we're pretty convinced that we're going to see this type of regulation pretty much statewide, which means probably nationwide eventually. And from a groundwater pollution standpoint, we've been putting a lot of nitrates in our groundwater and well water, and it's a human health issue. It's an environmental issue as well. So we need to do something about it, but there's a lot of nuance. And there's been some great folks in the Salinas Valley working on how cover crops might play into this. Dr. Eric Brennan with the USDA, for example, is looking at the carbon-nitrogen ratio of cover crops that you grow and how that would really play into the removal of nitrogen from these systems. And there's other folks, interested, and I think an area of interest for our center is really, okay, how do these fertility products play into this? Because, right now the way the law works, it's just looking at nitrogen, and they're not really looking at the form of nitrogen. So again, if you're using a synthetic nitrogen fertilizer, it's basically pure nitrogen, and it's already mineralized. It's in urea ammonium nitrate form. So it's basically almost plant ready and also leach ready. If you apply an organic fertilizer, there's almost no nitrate in it to begin with. It's all amino acids and proteins that get broken down by microbial activity into those plant available forms. You know this better than me. But that isn't really reflected in the regulations in the law. So whether I'm putting nitrogen on as an amino acid or I'm putting it down as a fully mineralized, leachable form, I'm treated the same. But ultimately, that doesn't really make sense because, probably those more complex molecules are not going to lead to leaching as quickly. But there's a lot we don't understand and a lot of research to be done. And that was a big, long way around the barn to answer your question about our Ag Order 4.0. So the short answer is it's about how much nitrogen you can put on. It's decreasing over time. It's not really taking into account the nuance of the nitrogen cycle. And it got struck down, but we expect it's probably going to come back.
Yeah, still seems worth talking about.
Yeah, and again, we need to do. This is an issue in the Midwest. This is an issue everywhere there's heavy fertilizer use. We really do need to do a better job with our fertility programs to minimize the off-target impacts like the human health hazards of high nitrate or the environmental issues like you mix that nitrate with some phosphate, now you've got a recipe for eutrophication in groundwater, which leads to dead zones like the one in the Gulf of Mexico. But I feel like I'm being a professor again. Maybe you have to, yeah. So what are you hoping to do when you finish, Shane? Maybe that's a good way to go out on our conversation.
Yeah, I suppose so. I don't know. I've really enjoyed learning so much about agriculture and organic agriculture in this time of my master's. I feel like the main career path I would be looking at right now is maybe trying to pursue a CCA certification and maybe working in some sort of laboratory space or something like that in an agriculture facility. I feel like that's something I'd be quite suited for. So lab work is a lot of what I do.
Yeah. So like a soil fertility lab or something like that.
Yeah, something like that.
Well, I certainly think there's going to be a future in that because we're really just scratching the surface, especially when you get into the more organic fertility regime.
Yeah, exactly. It's
so much.
Organic agriculture it poses such unique and interesting problems to me, I think. I don't know. It's very interesting. It seems like.
Well, it's amazing. I mean, when you take a big tool set away, suddenly you've got to get creative with how you use the tools we have remaining, right? And there's a reason why we went to mineralized nitrogen fertilizers and everything. They're easy. Right. They work very consistently. Unfortunately, like a lot of things, their overuse has some serious consequences. But they've been pretty widely adopted.
Pretty popular.
Very popular. Yeah. So we're moving back a step is interesting. It's going to be a challenge. Well, that's great. Well, thank you so much for sitting and sharing your experience here and letting me prattle on a little bit. And Yeah, maybe we can have you back when you're getting closer to graduation and hear about the outcomes of your research, Shane.
Oh, yeah, absolutely. Thank you for having me.
All right. Thanks for listening to Organic Chat. This podcast is recorded on the Cal Poly campus. Production provided by our production engineer, Mary Nascimento.